Welcome to AI Frontiers. Today's episode explores a pivotal moment in artificial intelligence research, December 15, 2025. On that single day, 92 new papers were uploaded to the arXiv preprint server, all focused on computer vision. This collection represents a snapshot of the field's explosive evolution, marking a fundamental shift from machines that merely perceive the world to systems that actively create and reason within it. We'll journey through these papers to understand how machines are learning, not just to see, but to dream. This analysis will journey from raw pixels to intelligent partners. We will systematically examine those 92 computer vision papers from that single day. The exploration will identify 6 dominant research themes reshaping the field. Groundbreaking findings that are shifting technical paradigms will be highlighted. 3 seminal papers that define the current frontier will be examined in depth. Finally, we will look ahead to where this transformative technology is leading us next. Computer vision is fundamentally the interdisciplinary quest to give machines the ability to extract meaning from pixels. The field was traditionally focused on perception tasks like recognition, classification, and segmentation. The new frontier, as evidenced by the recent research, has expanded dramatically into synthesis, reasoning, and interaction. The goal is moving from building tools that passively analyze the world to creating partners that can actively co-create within it. This evolution establishes the foundation for multimodal, embodied, and creative artificial intelligence, redefining applications from entertainment to clinical medicine. The first major theme resonating through the research is generation and control. This moves beyond basic image or video generation to demand precise, steerable outputs. For example, PoseAnything by Wong and colleagues uses arbitrary skeleton poses, not just human ones, to guide video generation for any character. EEER3D by Ma and team allows users to modify generated 3D objects with simple text commands, like making chair legs taller. The overarching goal is to develop AI as a collaborative creative partner, not an opaque black box, enabling intuitive tools for filmmakers, designers, and artists. The second critical theme is efficiency and scaling. As models grow more powerful, they often become computationally expensive and slow. Research is focused on bending this cost curve. LitePT by UA and colleagues introduces a smart hybrid design for processing 3D point clouds. The Transform Train Transformer, or T3, work by Zhang and team achieves over 10 times faster generation of native 4K video. This work is essential for moving state-of-the-art capabilities from research labs to everyday devices, enabling real-time applications on mobile phones, autonomous vehicles, and augmented reality glasses. Theme 3 is generalization and robustness. A key challenge is whether models trained on data from one condition, like sunny days, can perform reliably under different conditions, such as foggy, rainy nights. Recurrent Video Masked Autoencoders, or RVM by Zeron, and team learns powerful general video representations efficiently, towards scalable pre-training of visual tokenizers for generation, or VTP by Yao, and colleagues addresses fundamental flaws in how core generative components are trained. The aim is to move from brittle, specialized models to adaptable, generalist systems, which is critical for real-world deployment in unpredictable environments. Several key findings from the day's research stand out as paradigm-shifting insights. First, a breakthrough in visual tokenizer training demonstrates that understanding is a key driver of generation, as shown by Yao and team. Second, the discovery that instance models can act as spatial reasoners, unlocking hidden common-sense knowledge about object arrangements, was made by Ling and colleagues. Third, a simple yet powerful method for test-time adaptation uses image translation for robust perception, developed by Jaden and team. Fourth, reinforcement learning is maturing from mastering games to executing real-world strategic decision-making. These insights are redefining how vision systems are built and deployed. Underpinning these advances is a consistent technical toolkit. Diffusion models and flow matching remain the gold standard for high-quality generation due to their output fidelity. Transformer architectures serve as the default backbone, with innovations focusing on hybrid designs for efficiency. Retrieval-augmented generation enhances models by allowing them to consult external knowledge bases. Self-supervised pre-training on vast unlabeled data is now a foundational step for learning powerful representations. Finally, reinforcement learning from human feedback and direct preference optimization are critical methodologies for aligning model outputs with nuanced human preferences for quality and safety. The seminal paper exemplifying interactive creation is Diffusion Browser. Interactive diffusion previews via multi-branch decoders by Su-Sung Han and colleagues. This work directly solves the black box weight problem inherent in diffusion models. The method attaches a lightweight multi-branch decoder to a frozen pre-trained video diffusion model. This decoder can generate coherent previews including rough RGB video and scene intrinsics like depth maps from any intermediate generation step in less than 1 second. This capability enables real-time guidance and control during the generative process, effectively turning batch processors into interactive creative studios. Another seminal paper focused on intelligent efficiency is LitePT, Lighter Yet Stronger Point Transformer by Yuanwen Yue and team. This work revolutionizes the efficiency of processing 3D point clouds, which are crucial for robotics and autonomous driving. The key insight is that not all network layers require expensive global attention mechanisms. The LitePT architecture uses cheap, local convolutional operations in early layers to capture low-level geometry and reserves powerful attention mechanisms for later layers where high-level semantics are needed. The results are striking. The model has 3.6 times fewer parameters, runs twice as fast, and uses half the memory while matching or exceeding the accuracy of its larger predecessor. This provides a blueprint for deploying advanced 3D vision on edge devices. A third defining paper charts the path towards interactive intelligence for digital humans by Yi Kai and colleagues. This research defines the next epoch for digital avatars, moving them from scripted puppets to interactive partners. The authors introduce the MIO framework, which integrates 5 specialized modules: a thinker for cognitive state, a talker for personality-appropriate speech, face and body animators for expression, and a renderer. This unified architecture integrates high-level reasoning with real-time, multimodal embodiment. The framework creates avatars capable of personality-aligned expression, context awareness, and even learning, charting a clear path from animated graphical shells to convincing interlocutors. Looking at the road ahead, several future directions are clearly indicated by the research trajectory. The development of unified multimodal world models that enable coherent reasoning across vision, audio, and language is a major goal. Efficiency-first design will become the norm to democratize access to advanced AI capabilities. Interactive and steerable AI will transform users from passive prompt writers into active directors and collaborators. Achieving deeper causal understanding, teaching models the why behind the what, remains a nascent frontier. Finally, the societal integration of this technology necessitates building ethics, safety, and detection mechanisms from the ground up. This synthesis was created using an AI-assisted workflow. The narrative was generated using the GPT DeepSeek model, specifically DeepSeek Chat. Text-to-speech synthesis for audio narration was performed via DeepGram. Visual concept generation utilized Stable Diffusion. The entire content was reviewed by a human expert for accuracy, coherence, and technical validity. It is important to note that while expert-reviewed, some minor oversights may still exist in the synthesized material. In conclusion, several key takeaways emerge. Computer vision has fundamentally shifted from a discipline focused on perception to one dominated by creation and reasoning. Progress is driven by a dual engine. Breathtaking advances in multimodal generation are paired with a crucial focus on practical efficiency. A significant and growing portion of the field's energy is dedicated to societal implications, including synthetic media detection, bias auditing, and privacy protection. The research indicates the field is maturing, building not just the engines of creation, but also the necessary steering wheels, breaks, and maps to navigate an increasingly synthetic future responsibly. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.